Good morning, ladies and gentlemen. Welcome to the second day of REI Expo 2.0. This is our first session of the day and one of the most potent sessions which brings you technology and innovation. The session topic is Think Quality, Reliability, Performance, Decoding CXO Vision. The session aims to bring together visionaries and pioneers from the RE space, and it will delve into what each stakeholder can contribute to ensure the convergence of renewable energy with the upcoming opportunities in the rapidly emerging domain. Our first presentation for the day is by Mr. Tang, Director, Product Technology Department, JA Solar Technology Company Limited. May I please invite Mr. Tang? His topic of presentation is 450 watts plus mass production and 525 plus DeepBlue 3.0 launch. Mr. Tang.
Hello, everyone. May I start? Okay. But I can't see my representation on the screen. Okay. Thank you. So first, I'd like to express my gratitude to everyone for attending my briefing on the start of mass production of DeepBlue 3. So over the last 3 months has passed since the launch of DeepBlue 3. However, in such a short period, JA Solar Technology has actively prepared for mass production of DeepBlue 3. So with a view to providing our customer with a high power and a high quality products at an early date. So now I'd like to brief you on our preparations for mass production of DeepBlue 3. So next page. Yeah. And then next. Okay. So on 24th June, 7 photovoltaic companies, including JA Solar, established the M10 Alliance and issued a joint statement that adopts 182 millimeter as the standard size of the M10 silicon wafers. So obviously, this interaction in the industry has brought us win-win. Where we all know that the size of silicon wafer is set in the scale of 180x for the consideration of packaging and transportation. But every increase of 1 millimeter within this range will lead to an increase of 5 watt in terms of the module power. So I think no company can resist such a temptation when setting the size of silicon wafer. However, repeating this increase of size will lead to vicious competition, bringing us unnecessary waste and loss. So necessary industry standards are conducive to the common and healthy development of photovoltaic companies. Firstly, different silicon wafer specifications will cause confusion and lead to a waste of equipment, process, and materials as well, which will directly increase manufacture cost. We have limited time for 1 day. So if the size of the silicon wafers is standardized, and we can spend more time and on the more important technology of silicon wafers, cells and modules. And I think it's better for everyone. So secondly, setting an industry standard is for the benefit of customer. So imagine how confused our customer will be when facing different size of modules provided by different manufacturers. So this will save the time of our customers. And thirdly, setting a standard size for M10 silicon wafers is our obligation as a leading PV player. So it also set a good example for the next industry upgrade. So we can see the DeepBlue 3 products with standard M10 silicon wafer represents a standardized product in the chain of a large size module, providing a strong support for future profit growth of customers. So next. Okay, so let's take a look at the parameters of DeepBlue 3. What makes our product stand out are the core technology of cells and modules, such as temperature coefficient of modules, low iteration response, and warranty for single and bifacial modules. These product parameters are a good representation of Solar's strengths in technology research and development. For product type, we also launched a 66 cell products, which will satisfy some of our customers' needs for size flexibility, while maintaining the advantage of 72 cell products at the same time. So next. Okay, according to our pilot run of DeepBlue 3, the estimated distribution of power is showed here, and the highest power can reach 545 watt based on this result. And this encourages us to get an even higher performance in the following real mass production. So next. So the current technology used in the high efficiency modules are based on the optimization of the module size. And that is to say the high efficiency of the modules essentially lies in the reduction of the overall size of the module, and does not involve any improvement in technologies of the real cells. So there's nothing wrong with this design idea, but we shall pay attention to what are the priorities. So we have made some improvement in two aspects. On the one hand, we have removed some redundant design area by improving module process, without greatly reducing the power of a single module. On the other hand, for those areas playing a key role in the module generation, such as the setting of the cell spacing, we have offered a high power and high efficiency module for our customer, and that is a normal spacing module and paving technology module. So next. And for the increase of our mass production capacity, this table clearly shows that in the coming 1.5 years, our production capacity of DeepBlue 3 products will continue to expand at a reasonable rate, and will reach about 20 gigawatt by the end of 2021. And I think such a production capacity ensures our stable supply of products to our customers, and making DeepBlue 3 our most important and mainstream product in the next few years. Next. Okay. For the future, based on the current DeepBlue 3 product, we will actively develop 600 watt plus products in the spirit of one generation mass production, one generation reserved, and one generation research and development. I think it should be noted that the media are leaning on hyping us up as two opposing camps, but I think it's not quite such a case, and the interest of our customers lies in high power and high efficiency modules, which requires us to make constant effort. So what kind of technology is developed to achieve the goal depends on the technological development of industry at the time. So Solar technology has been upholding pragmatic and open attitude. Being open means that we need to conduct we need to conduct research on various potential technology, and being pragmatic means that we will apply the mass production technology with an aim to bring high yield and high quality modules to our customers. And it can be said that there are endless possibility in the future in terms of the module type, and the future starts from now. So finally, thank you all, and wish our DeepBlue 3 mass production a great success. Thank you.
Thank you so much, Mr. Kun, for the lovely presentation. And thank you for keeping a check onto the time as well. Thank you so much. May I please call upon Mr. Idrish Khan, CTO, Ginlong Solis Technologies, for his presentation. Mr. Khan, please.
Thank you, Amit, for the introduction. Let me share my screen. Is my screen visible?
Yes, it is. If you can do it to full screen, please.
Okay.
Yeah.
As Mr. Quinn has enlightened already, the technology is evolving day by day. And at the same hand, module technology is going to be improved in coming days as we see the watt peak of PV module and the wafer is increasing. So at the same time, inverter should not also need to be capable enough to deal with those kind of power. So looking on those aspects, Solis has also wanted to bring a technology so that it can able to match the requirement what is being going to be introduced in the market. So talking about the inverter power capability, so Solis 255 kilowatt is the highest inverter as of now in on date that it can able to generate 255 kilowatt of power in string inverter category. And we will see in a later on slide what what are the key points of this 255 kilowatt. So I'll just go through with the three elements. One would be the in the company profile, very short introduction. I will like to share it, and then we'll be talking mainly on the technology part, which is the 255 kilowatt inverter and 1500 volt, and some of our the reliability test which has been conducted by third party. So talking about Ginlong technology is been started in 2005 as a R&D company in Ningbo. And you can see there are certain landmarks we have crossed in every particular. So in 2009, we can see we have got a complete full chain of manufacturing process. And 2012, we have introduced a joint R&D academy in Shanghai. And 2015, we have got a recognition that one iconic installation has done in Eiffel Tower. So that's how we are keep on growing in year on year. And in 2019, we have now listed as a stock listed company in Shenzhen. And in 2020, we are celebrating our 25th and 15th anniversary. So as you can see, every year on year, we have able to get some new milestone. Some more detail about the company. We are holding more than 200 million of total asset. Global employees are worldwide is more than 1,000 plus, and 200 plus R&D technicians are working day and night for developing the technology what we want to introduce in the market. And till date, we have supplied globally 15 gigawatt of inverter capacity. So almost like you can see every year we are able to contribute 1 gigawatt, but it's not like that. It's like last 3-4 years we have able to contribute as able to supply in a good capacity. Some other information like about bankability in 2000 comparing to 2019 2020 Q1, the sales revenue has been gradually increased by 76%, and that is because of we have been introducing our new technology inverter every year on. So last year we have introduced fourth generation platform, and this year we are also releasing our fifth generation platform. So as the product quality and the technology innovation is continuous, so that's the reason we are able to get more trust on our on Solis brand. So by end of 2020, we would be able to manufacture 20 gigawatt of capacity. As of now, the 5 gigawatt of the annual production capacity we have in factory in Ningbo, and a new factory which is in under construction would be finished by the end of this year or probably the first quarter of 2021. So the new factory altogether will make a total manufacturing capacity of 20 gigawatt. We have been listed by Bloomberg as a top three Chinese inverter brand as a bankable inverter, and also there are some other financial institute has been listed Solis Ginlong for their good credentials. So now we move to the technological part. So wanted to what is the 255 kilowatt inverters all about? So as we have got a 15 years of good experience, and because of that years of experience, the new machine and the development can become easy, because the things that we know what all things has gone wrong in past, and keep on continuing the improving the design. That's what we could able to achieve such a high power class inverter into 55 kilowatt segment or in string inverter category. So talking about highlights of this particular product, it is having a 14 mppt independent mppt where we can connect 28 dc inputs. The efficiency of the product has increased to 99%. And as the DC input current capability also need to be enhanced, because as the PV module manufacturers are current ISC, the short circuit current, and the IMPP is now been increasing because of bigger wafer size. So at the same time, inverter should also able to match that requirement. So input per input capability of the inverter is also increased by 15 ampere. The DC voltage max is able to harness 1500 volt, and that we have already seen in the industry. It is now trending, and people are only opting for 1500 volt for a bigger plant because of the other advantages. DC balance of system say optimization can be done with 1500 volt, and as well as at the AC side, the 800 volt AC output, which is also giving an advantage to have an optimization on the AC costing part, like the cables and other breakers can be optimized with the higher voltage with the less power losses. So these are all trending at this moment in the industry. So considering those requirement, Solis 255 kilowatt is been designed to cater the current market demand, as well as it can fulfill the demand which is coming in future. And it is environmentally it is a foolproof design, can be installed in outdoor area. It has an IP class of 66. So talking about some key features about Solis 255K inverter, we have bifurcated into four different category. Talking about higher generation yield, which is the always a hot topic and a concern from a developer point of view, that how much amount of energy can be converted from a solar inverter, and this and so based on that, what all things can be considered, like independent MPPT is the one of the key feature which is like able to achieve the highest generation yield, because every independent MPPT will be idle to find out the maximum operating point of a PV panel. So as if like there are 14 independent brains are working all together to find a maximum a power point from a PV module. So that's what already has seen in industry, and people have witnessed that is a generation yield has increased based on because of number of MPPT. Another capability is that the hardware should uh, able to take maximum amount of DC-AC ratio. So in India, it's already like people have seen the difference benefits, like doing 150% oversizing and beyond that, so that it can able to enhance their generation yield as well as the return of investment. All those calculation makes more easy if if the hardware or a device should able to deal with that. So 255 has a very wide DC ratio can be considered between 150% to 200%. So even in future, if any wafer size has been increased from 185 to 210 or even beyond that, even maybe, so that can be easily can accommodate in the inverter, so that it doesn't become a bottleneck. So it has considering four inverters per megawatt would be having 56 mppt per megawatt, which can increase the higher generation yield. It also compatible with the bifacial model technology. Continuous output power of an inverter can able to generate at 50 degree, because in India, where the temperature is very high, and we need to consider that part, that how at 50 degree what would be the power can be delivered. So that is where inverter is able to generate 220 kilowatt, which is also a highest among any other string inverter category. Talking about smart OM, because it is very much necessary, because string level monitoring is very much required. We need to know what is happening in our string, so it is also gives you ease of O&M activity. One click scan for finding out the monitor to see the what exactly happening in your PV modules. It support broadcast command to understand that, to control the active power and reactive power based on the demand which is going to be raised by the discoms. Talking about safe and reliability, inverters are like equipped. Yeah, I'll
Mr. Khan,
just
I'm so sorry. We'll have to cut you short now. I'm very sorry about that. Yeah, we're done with our 10 minutes of presentation, and I'll have to call upon Mr. Rohit Kumar. Uh, Mr. Rohit Kumar is head of Indian subcontinent REC Solar, and he's the director with REC Solar, REC India. Rohit, the stage is yours, please. Thank you so much.
Thank you, Amit. Thank you. Yeah. Good morning, everyone. This is Rohit here from REC. Before I start my presentation, what I'd like to say is, REC is moving in a slightly different direction as compared to most of our competitors today. While our competitors are running towards 500 watts, 600 watts, I think we have heard of even higher watt class announcements in the recent past. We are focused on, increasing the energy density. And to do this, what we are doing is we're taking a technology leap here. While most of our competitors are ramping up on their P mono capacities, we have moved into, a couple of generations ahead, that is N-type, and then beyond that is the heterojunction technology. So a quick snapshot about REC. We are almost 25 years old now, and we have manufactured over 38 million solar panels from Singapore. And we are powered over 16 million people. Our manufacturing capacity is 1.8 gigawatt, which doesn't make us the largest one among the largest ones. But again, as I said earlier, we are taking a technology leap here. And on the technology side, we are among the market leaders. Our manufacturing is based in Norway and Singapore. Our finished good comes out of Singapore here. And one of the key USPs of REC is that is the quality consistency. Wherever you buy our product from, you get the same quality, be it India, Australia, Japan, US, Europe. We have only one factory that is based in Singapore. All lines are similar. All bombs are of the same quality. So that's one assurance which REC is quite unique at as compared to most of our competitors. On the sales organization side, we are split in three parts: Americas, Europe, and APAC. India reports into APAC, and we are responsible for SAARC countries, Middle East, and Africa. On the go-to-market strategy, we have a very structured approach, especially into the rooftop market, which is one of our key market segments globally and also in India. So we have a two-tier structure. First is the distributors, whom we tier in two levels, platinum and authorized distributor. And then we have the certification program for the installers. So what we try to do is we extend our best practices from a global experience into the installer segment in India also. And considering India is a developing market, it becomes quite important because there's a learning curve for everyone. And what we intend to do is make sure the best product comes as a best system and is implemented in the best manner for all our consumers. So talking about Alpha series, which is our heterojunction technology, as I said earlier, our focus is on high power density. And even beyond that, we are looking at higher energy density. So as a consumer, if you look at your rooftop, you're going to solarize it only once in a lifetime. A solar module lasts for 25 years, 30 years. So the key here is, what we believe is you need to focus on the energy density side and go with the product which gives you highest energy density, reliability, and longevity of the technology. And this is where Alpha tops, in the solar module technologies. And we offer this in three variants: Alpha 60, Alpha Black 60, and Alpha 72. Alpha 60 and Alpha 72 are already BIS certified and readily available in India, and Alpha Black is also available, excluding India. It's available for rest of the world. So on the just to compare it with a P multi or P mono technology, this is for a small residential rooftop in the same space. You go up 20 to 27% in capacity here if you're going with Alpha series. So, and this is just on the capacity side. If you talk about the other benefits, you'll see that the energy yield also increases substantially, and you'll see in the subsequent slides how it goes. So on the technology slide, it's basically a N-type mono wafer, which is sandwiched between thin film, which is amorphous silicon. So this gives you the best of two technologies, which is low temperature coefficient, low light behavior, irradiance behavior, and then the benefit of N-type is zero LID, very high reliability. And then what we have done again is we have removed bus bars from the cell surface, so the cells are lead free. So we're looking at environment friendly also, and and this technology has the highest bifaciality in the world today. So right now we don't offer bifacial modules, but we'll be doing that pretty much soon. So on the second innovation here is the connectivity here. We have done away with bus bars, and instead of bus bars, which are which entail a higher level of stress on the material, and it takes a higher level of temperature for the soldering. We basically are doing a simple lamination of 16 thin wires on the cell surface. So this make sure that this helps in enhancing the connectivity in the modules and also improves the reliability manifold. How we do that here is very simple. To give a comparison, a 5 bus bar cell versus a Alpha series here. It's this is the red crosses signify the number of solder points on the front and the equivalent number on the back side. So each half cut cell has 50 solder points, and you look at Alpha on the right side, there is no solder at all. So you're basically eliminating all the soldering, which is done at 800 degrees centigrade, and the lamination is done at 200 degrees centigrade. So we are reducing the thermal stress on the cell material, and at the same time we are increasing the number of cell connections substantially. So this basically improves the performance and improves the reliability in one shot. As I said earlier, LID is 0, and so what you buy is what you get. There is, if you buy a 450 watt Alpha series module, you install it, it still is a 450. Compared to that, other products have power losses from 0.5% to 1.5% to 3% also, depending on the technology there. Now, this is how the lower temperature coefficient helps. If you look at the peak time, the energy yield is much higher as compared to any other technology. So this is primarily because of the temperature coefficient, and this is how it stacks up. REC Alpha series temperature coefficient is typically 30% lower than most of our competitors. And another pictorial, another representation of how it impacts. The yellow line is alpha series. So during peak hours, you see the losses are minimum and the performance is best as compared to most of the other technologies here. And this also comes in a super strong frame. We have the thinnest frame, 30 mm, and with the support bars on the backside, this helps us make the frame very strong. And while the product looks very, delicate, it actually is one of the strongest products there. On the cell side, there's a good video on our website. You should go on or on YouTube. If you see this video, it's a few seconds. You can actually press the cell all down to the bottom and make the cells touch the surface or the ground there, and the cell will not break. It will come back to its normal state there. So this is how durable the heterojunction cell is. So you can imagine when you're buying a product for 25, 30 years, this is what you're investing in when you're going with heterojunction technology. And as I said, we have a thin frame, and beyond that, we have also given additional flexibility of using larger area across the frame. So this provides flexibility when it comes to rooftop installations. You can maximize the space utilization, and don't need to worry about warranty claims being rejected if the module is not installed with the right clamping zone. Lead-free cells, we have reduced lead content by 81% in 60 cell and 84% in the 72 cell. And our target is to come out with a lead-free product in the future, which we'll hopefully see next year. This is a quick snapshot how we have moved our technology from polyperk to monoperk to heterojunction. So, if you see on every key parameter, almost every key parameter, we have made sure we are going upwards and offering a better product to our consumers here. The manufacturing facility again for Alpha is the latest. It comes with the Industry 4.2. I don't want to talk about a lot about that right now because of the time limitation, but this is basically gives you the best of reliability also. Warranty claim rates, we are among the lowest in the world and consistently there. And this is despite having different products and different technologies being brought up by REC over the years. This is the last slide. We have the best of warranty terms, 20 years product warranty, year-on-year degradation, 0.25%, 92% at the end of 25 years. So we're offering you the best of technology with the best of warranty terms across the world. Thanks, Amit. I think I'm done here. So
thank you so much, Rohit. Thank you being so precise, and the presentation was wonderful.
So that's my timer also.
Yes, thank you so much.
A couple of seconds before.
Yes, thank you so much, Rohit. It was a pleasure. Now, may I please invite Mr. Filippo, Board of Director and Chairman, FIMA Group, for his presentation, please. Mr. Filippo.
Thank you very much, and good morning to everyone. Let me share my screen. Good. Do you see my screen? I hope so. Okay, let's start with our presentation. And thanks first of all to inviting me. It's a very pleasure for me to be here in this virtual event. In normal condition, I would have been glad to be in India in person, but I'm really happy to participate to this virtual event format. Let's start with a number, 94%. After the acquisition of the entire solar business of ABB, our company has been focused mainly in solar and in renewables, and 94% is the percentage of the solar business in our company. The other 6% is represented by the EBI, so the electric mobility infrastructures that made FIMA 100% a renewable company. And being focused on the 100%, on the 94% in solar, that means that all our strategy, all our decision, all our focus is on solar. And we deeply think that having this kind of focalization on the solar business is the only way to be reliable and always innovative in this sector. Thanks to the acquisition of ABB, we are merging different team and different people and different cultures in our team. We deeply think that people are driving the progress of our company, and only with the passion, the ambition, and the boldness we can achieve our strong goal. And this merge of people with different experience and different cultures reflect perfectly the female values, and it shape our identity. And we think that only thanks to the interaction and integration between people from different countries and different experiences, we can reach all the goals of reliability and competitiveness and flexibility that are coming from a big conglomerate and a big company of ABB in the past, and now very flexibility and speed of female today. Those are the elements that we are merging into this new era, and especially advanced solutions, because the company has been very focused in R&D. We are, I think, one of the strongest company, and we have one of the strongest R&D team at the global level, in the global scenario of the solar string manufacturer. With 3 research centers, 1 in Finland and 2 in Italy, with more than 250 people working there. We have a global footprint because we have the most capillary presence in the global level, with 26 legal entities spread in 26 different countries, covering all the market region in the 5 continents, and a very strong, reliable quality, because we are caring much more after the acquisitions our quality and the reliability of our product. What I always say to our people is that one thing is to design a reliable product, and the other thing is to think that our products are installed for 20, 25, 30 years, and we need to maintain and guarantee our reliability for the entire life of the plant. And we are adding more elements that are necessary to be successful in the solar market, that are speed, solar focus, as I said at the beginning, so more than 94% of our business is there, and flexibility. Because only being fast and really flexible, you can adapt your strategy accordingly with the markets and the customer needs. Because the solar market is changing very fast, and every company must listen what are the changing of the market and be very focused in the strategy accordingly with the market changes. Now you may wonder why I'm showing you penguins, but there is a specific reason. This is the Uruguayan Research Center Artigas in the Antarctic. That is a natural laboratory for the environmental research from Uruguay. This is the second plant that we are installing there, and it's a very specific installation. Why? Because we are arriving at minus 40 degrees, and with the winds that reach 200 kilometers of speed, and it's definitely a challenging environment, and it was a successful project only thanks to the reliability that we put in our installations and in our inverter. And because with the quality and the reliability we are putting in our activity, we can reach really extreme environmental conditions without any problem, and that's just an example. Some insight about the project. This is the second project that we are installing there. The first one is running since a couple of years in a very reliable way without any failures, and that's a very success for us. The partner is the Instituto Antártico Uruguayo for the Environmental Research Center, and thanks to the female technology, they have a very strong and reliable installations for their research center. What we saved, just to give you some insights, the 10% of the total demand is powered by our solar. We can power 1,415 TV for 1 year, and as a day we can power for 40 personal computer for 1 year in these installations. This is another example of installations in the opposite environmental conditions. So this is the Villanueva project in Mexico. It's one of our biggest installations with 830 megawatt power. It has been installed 1 year and a half ago. We have special conditions like this are a desert, but with something better, because we arrive at 45, 48 degrees during summer with a very dusty environment with a lot of sand everywhere. But in winter, we can have snow. We have pictures of these installations where we have snow and minus 0 degrees during the winter, and extreme hot and sandy conditions during the summer. And that could be possible thanks to the technologies that we applied to our inverter to reach the maximum of the reliability. This is instead one installation in India that we just commissioned, 8 megawatt in the Andhra Pradesh state, with the newest technology of our central inverter with the PVS 985 megawatt. Just a short video about the commissioning phase. That could be possible only because FEMER invested tens of millions of euro of investments in our laboratories and in our testing facilities. In our 3 research centers in Finland, in Helsinki, and 2 in Italy, we have one of the most advanced equipment to test and to design our inverter. One example is our climate rooms that can reach minus 40 degree up to 80 degree with 99% of a humidity range, and we can change our temperature and humidity of 1 degree per minute at the full power of our inverter. So we can test our inverter in every condition, in every grid condition, and especially in every environmental conditions to reach the reliability of our product. So you're ready. Progress only happens when you are pushing the boundaries, and we are offering to our partners a really strong combination of flexibility and reliability. And our advanced solar and EVI, because it's our second business unit, have to push the limits where it's possible. We are focused. All our strong investments are in R&D, especially in quality, and in service, of course. Let's get a step in a new year. Thank you very much.
Thank you so much for your presentation, Mr. Filippo. Very nice presentation. Thank you so much. Now, may I please invite Mr. Ghosh, Mr. Sandeep Ghosh, EVP Solar, Livguard Energy Technologies Private Limited, for his presentation. The topic being Decoding the Future Market Trends. Mr. Ghosh, please.
Are you able to see my presentation?
Yes, please.
Right. Thank you, Amit. So let us look into something. Till now, my previous presenters have put the technological perspective of the future trend. Now let me just take you through to the business trend in India. So to start with, let me just put my own company detail. We are into energy storage space. Wanted to be $1 billion USD, 4-year-old company, and doing pretty okay. Presently, we are doing around 2,500 Indian rupee crore. So we work in energy storage from car to solar as well as inverter. So medium-term target is to be top 2 brand in India on an energy storage space. So let us look into the energy scenario in rooftop space. Now, we all know that 40 gigawatt has been set by Government of India. Out of that, 5.5 gigawatt is in rooftop space. Now, if we look into residential, it is 1 gigawatt. And if we start looking into industrial, commercial, and residential, industrial is around 45% out of 14 million gigawatt hour which is consumed. Commercial is around 8% and residential is around 25%. So for further analysis of the market, let us try to understand what is going to happen in industrial sector. Even to get 5% of industrial sector is quite difficult in present scenario because discoms are not preferring to go with the rooftop, obvious reason. Commercial space is a problem. Again, 3% of commercial rooftop will be a little bit difficult. This leaves it to the residential sector, which has a potential of around 12 gigawatt. If we consider 5% is actually houses or 5% of energy is from solar. So looking into that one, residential starts looking in a viable option in medium to long term. Now, if we start looking into residential from the perspective of the houses in urban area and rural area, we start looking into a 80 gigawatt of solar market if we do more than 3-bedroom houses solarization only. So that actually becomes a 9,000 crore per year of the business potential if 30% is being done. Now, rural, I am not going to touch more because it is more on a discom pain area and Government of India through Kusum is trying to do a lot of work on that. Now let us look into the CNI segment. Post-COVID, I think it is going to be a little bit suppressed market. Only silver lining which we could see it at this point of time is MSME segment, which is more neglected, which was neglected by everybody till now. That can make a CNI segment grow. So we estimate it will be around 2,000 to 3,000 crore of business on this segment, MSME. But one thing you need to look into from here is solar as a service has to be provided. Finances are the big problem for them. So you have to approach them with arranging finance for them. Now let us look into the residential sector. In one hand, the potential is 80 gigawatt or 9,000 crore per year market. And another hand, it is around 12 gigawatt market. If we look into 5% thing and 25% of power consumption. So looking into both the things, it looks like there is a 2 to 2.5 gigawatt of market exists if we work properly. So 2 to 2.5 gigawatt market is around 6 to 7,000 crore market. So let us get into the thing, residential market, how we are going to look into the residential market. So the first thing is the customer. Now, customer is basically wanted to get an assurance that whatever investment he is doing on solar, it is going to provide the saving. And a properly designed system, a proper and prompt service, a long-term association is what he is actually looking for. So let us look into the present way the solar rooftop business is being done. So present way, there are two business models which is actually there in solar. One is subsidy-driven business model. Prices are fixed, nodal agency is involved. Most of the time, local players are there. Customer access is limited by them because of they are local. Quality of system, since they have bet lower price, they will not be able to provide good quality system. Customer does not get money as finance, very difficult for them to get it. Subsidy disbursement becomes quite difficult. Net meter, again, DISCOM has its own problem. Another way or another business model is through dealer networks, which is a very price sensitive market where typically inverter or off-grid system are being sold. Design, they don't design. They just push the kit to the system. Again, whoever comes to them, that is the customer. So let us try to understand whether our business model today is able to cater to the customer demand. Answer is no. So let me just try to analyze a little bit more on customer question. So when customer is asking that solution should be designed or solar solution to be designed as per his requirement, you cannot just push on, take grid connected inverter of 3 kilowatt or 5 kilowatt. He required systems, he required options, whether I need a small battery or big battery, whether I need a grid connected system. Second thing customer is always looking for is, what is the service? 25 years you tell, but whether you will be supporting me for 25 years. It means there are a lot of infrastructure need to be created. And third thing is customer also wants somebody who is very near to him. There is a face in his locality. So putting all these together, this is the customer need. Whether we are able to provide it in the present business models, no. So what happened? Infrastructure big companies can always provide, but they cannot be near to reach to all the customer at a time. Local people or system integrator and solar dealers cannot provide the infrastructure, but they can be local face. So that actually is what we are seeing is that actually is bringing them to a new business model where typically inverter battery retail brands and solar dealer and solar integrators are coming together. And they are trying to create a business model which is a infrastructure driven and local participation. It is giving both the world to them. But what they require, this is fine, business model is fine. What they require? They require actually subsidy driven thing, in our view, in our company view, is not a good idea to have it. Instead of that, let us get a net metering availability. Let us get loan to the customer. Let us get the solar benefit properly. And manufacturing stage in India or manufacturing in India should be pushed. And quality, I think quality is the one important thing. Let government don't decide about the quality. BIS, IEC is okay. Let customer decide upon the quality. And that is
so
all.
much, Mr. Ghosh.
Thank you.
Thank you so much, Mr. Ghosh. And in fact, I have to thank all our speakers who've presented till now. Everybody has been very precise with the presentations, and the presentations have been very lively. Thank you so much, Mr. Ghosh. Now, I invite Mr. Nikunj Patel, CEO, Australian Premier Solar Private Limited, for his presentation, please.
I welcome everyone in new era of presentation behalf of Australian Premium Solar and our team. As APS, our motto is to make people's life better. We start from our customer, our staff, and even the customer who are making the inquiry to us by giving the right advice to them. I personally consider whole world as one family, and I believe one nation should take care of another nation. And in same way, one person should take care of another person. I believe I have personal debt from Australia and India. I have completed my schooling and engineering from India and my master in advanced manufacturing management from Australia. I have learned love, care, and support from India and people from India. In same way, Australia and Australian people help me in a growth and respect. As a doctor, if someone can serve the society by taking care of patient, as a teacher, someone can take care of society by giving the right education to people. In same way, as a business person, myself with our team can support the society by creating maximum number of jobs for Australia, for India, and all over the world. Creating job is a first idea which motivated us to put a pillar of Australian premium solar in India. In Australian premium solar, we use TQM, Total Quality Management Strategy for quality. As many of us already know, the world, maybe I'm just little bit, maybe I just change the slide. So we all are on one page. Okay. For total means total quality management, the word total represents all staff, all level of organization and function pursue a quality. We make sure a word quality means excellence in every aspect of organization. And a word management means we make sure all our quality results via quality management process in strategy, in design, in manufacturing, and also in finance process. We achieve this via customer focus, process management, planning, process improvement, and total participation. Since start of the business, we use the 7S strategy for reliability of our business and start from our staffs. We believe our staff is our key for success. Our skills, our staff skill and our company skills, we try to increase by various training programs. The strategies, we believe strategies are very important for sustainable growth for businesses. Structure, we spend as and when required in infrastructure, software, machines to build the structure of the company. As a system, as our sales increase, we make sure our service team also increase. The style, we understand our strength and our weaknesses and decide the style of our business. We also use the DNA strategy to improve our overall performance. As we have limited time, I quickly go through one point in each strategy. In integrity, we as a team for all our staff and people, as an integrity, we focus to be a good human. We do right thing even when no one is looking at us. In advocacy, we do prototypes over meetings. In transparency, we believe that transparency breeds the trust, and trust is foundation of the teamwork. And because of that, 80% of our staff, like currently we have more than 350 staff working between Australia and India, and we do have many staff working with us since start of the business. In POFL, we use positive outcome focused language. Example, if we get the negative review from the customer, rather than saying it's a negative review, we just say we got a feedback from improvement. In DNA strategy, as a company, we always keep our growth in our mindset. We believe change is very hard in first, little bit messy in the middle, and always gorgeous at the end. We keep our momentum. In momentum, our favorite one is the magic of compounding interest. We started our business in 2006 with very little money, just say 4,750. On that time, we start from a garage. We start with one goal, how we can make our net value double every year. So that time, say since 2005, 2006, we were only focusing how we can increase our net value to 9,500. 19 means from 9,500 to 19,000, 38,000. From 2005 to 2010, we almost changed 7 businesses, and we started solar business in 2010 as a retailer in Australia. Since 2000 means even in 2005, we decide how we can continue to make our net value double every year. And last year, we crossed more than 500 crores of turnover between all our group companies without taking any bank loans. So we do understand the cash flow and very well, and we make sure our money makes the compounding interest almost double, and which we did in last 15 years. Now our goal is to grow 50%, 50, for our next 10 years. We believe we make the process very easy. We believe to scale the unscalable. Speed is very important in the DNA strategy, and that means we believe today is better than tomorrow. Right now is better than 6 hours from now. As Australian Premium Solar, currently we have more than 100 megawatt production line sitting in National Highway 8 near Gandhinagar, and we considering future growth, we already developed 500 megawatt of infrastructure facility in our new place and acquire land to cover up to 1 gigawatt. Also, in last 2 years, we have concentrated to develop the inverter products for residential rooftop and pump. There are many requirements from our customers who buy a solar panel. They always ask for a pumps for the government tender. As our main channels are retail and commercial rooftop and government tender supply, as an Australian Premium Solar, we have a target to achieve 3% of market share of India by rooftop market share by 2023. And we are currently doing up to more than 5% market share of Australian market. This year, we have installed and supply more than 150 megawatt of solar panel, inverter, mounting, including the installation. Australia is very wide in terms of the, say, almost 2 or 3 times larger than the India in compared to the location. We have developed very good software and even the training to staff. 80% of our staff is working from India, making the calls to the customer, taking the money from customer design. All our installers are, of course, local based. We have set up our small warehouses across the Australia, and currently we have an ability to install, give the service, and make a sale in each and every corner of the Australia. I thank you everyone for all of your time, and we look forward to see in coming future. Thank you very much, Amit.
Thank you so much, Mr. Patel. Thank you for keeping a tap on the time as well. Thank you so much. Now, may I call upon Mr. Siddharth Gangal, CEO, the Solar Labs. His topic of presentation would be solar design parameters to maximize project yield. Siddharth, the floor is yours, please.
Yes. Hi, Amit. Amit, can I share my screen, please?
Yes, please share your screen.
Yes. I have the option now.
Yeah.
I hope it's visible.
Yes, it is. Thank you.
Okay. Thanks, Amit. Good morning, everyone, to this presentation. Thank you, Amit, and the REI team for this opportunity. So we started the Solar Labs back in 2017 with a vision to enable solar growth through AI and through technology. So the company started off, with me doing intern. So I was at IIT Mandi, I did a lot of internships with professors. I did internships in the industry. So I got to know about how design and design parameters work on a practical level, as well as theoretically what could be done, through simulations in order to improve the yield. So through a lot of this research during university, we decided to start the company and provide tools to solar EPCs so that they can sell solar better, and they can also install higher performing, more optimized solar PV systems so that we actually get clean energy generated as much as possible. So the solar industry, as we all know, it's a huge $1 trillion market. Currently, we have around 37 gigawatts in India installed, and we are growing this at a pretty decent growth rate year on year. So what our software does is, our software basically helps anyone, in an EPC company, be it a sales executive or a design engineer, in a space of 15 to 30 minutes, create a complete solar PV design, which is precise, which is accurate, and which generates for you the energy generation figures for the next 25 years. It also calculates a financial payback. So the customer that we are pitching to can get to know about the rate of, the ROI, as well as present attractive 3D models, which actually help, in engagement, and which actually helps the customer understand what he is getting. So we've seen that in a number of our customers, they have transformed the way that they are doing sales. So, they have trained their sales executives to use the software, and in the first meeting itself with the customers, the final design is also done with the input of the customer that leads to more engagement and hence higher customer conversions. So these are some of the designs that have been executed from our software. And the vision for us is to enable, one software to help all the teams in an EPC. So be it the marketing team, which needs to create sales proposals and design reports and 3D models, to the technical team, which needs to have, CAD PV layouts, blueprints, shadow analysis, design optimization, to the execution team, which needs the blueprints. The software is meant to be the one-stop shop where you can save time, save money, and do everything on the cloud. And in addition to the software, we also provide some consultancy services. So we have tied up with the Energy Efficiency Services Limited, EESL, Ernst & Young, and a large number of solar consultancy providers in providing technical consultancy. So we can provide preliminary capacity analysis reports, detailed engineering, use of drones in design, and a lot more. We also have a large network of training providers through whom you can learn about solar, solar fundamentals, as well as solar design. So these courses are available through our YouTube channels and on Udemy. Another thing that we've done is we have started to work with enterprises as well. So one enterprise I can name for you is Tata Power Solar, where Tata is using the software internally, and also has given subscriptions of the software to all the channel partner network in the country, so that the channel partners are able to quickly design proposals and send them to customers, which eventually will help them convert more customers, right? In enterprise deals, we also work with streamlining workflows through custom integrations with CRM providers. We can also build software which enables better quality site surveys, using mobile applications, and do a lot more customizations in the design of proposal and much more. So if you're an existing developer with a very large footprint, we can help you streamline this process and give all the relevant KPIs so that you can manage your entire, India operations centrally. So this is one example of a survey we did with drones. So you can see that we took drone imagery of IIT Mandi, which is where I'm from. So we did the survey. Then from the drone imagery, we created 3D models out of the drone images. So these 3D models are insanely accurate. So they come within 3 to 5 centimeters of accuracy, which is more than enough for detailed and construction level design. And then capacity can be, this can be imported in our software, and then the capacity can be very quickly estimated, and final construction blueprints can also be delivered. So again, so we are happy to be contacted on these numbers and on our email. I'll also show you the software in work. So this is the software, right? It's cloud-based, so anyone can install this. It does not need to be installed; it can just be used from the cloud. And we can see that here, this is one reverse tilt shed that I have designed, which sort of shows you how the design process works and what's the final output. You can also see the color corresponding to a panel, right? So, so the color corresponds to how much solar generation that panel is getting. So for example, in a reverse tilt orientation, this panel is getting 95.9% energy, whereas because of this turbo ventilator, let's see, for this panel, it's only getting 93.9. So we really go into panel level optimizations, and the target becomes to optimize the solar access, and hence if the target becomes to optimize the total energy yield that the project can install. There are also more features such as auto panel placement, which allows you to iterate through all the parameters at one go for any site. So for example, we can iterate on table spacing or tilt and azimuth, define a solar axis cutoff. So let's say that I will only allow 5% of losses through through shade and other losses. So I can put 95, and then I can choose different table types to iterate upon. When I hit confirm, the software is going to give me 7-8 choices of the of various iterations, and then that will allow me to quickly pick one of them. So this reduces the amount of time it takes in designing, as well as it helps less technical people such as sales executives, which might not have perfect detailed engineering skills, to also design systems which are constructible and which are best in terms of optimization. So I'll also take a quick moment and show you the final report. So this is a sample for which I had created a sales proposal. So we can see that yes, let me just move this. Yes, so we can see here that you can put your details about us. There's also an option for a 3D model. While that loads, I will quickly go over to the next one. You can click about us. The system metrics are presented, so production, performance, specific generation. The savings analysis is also presented. So the total savings over 25 years, the payback period, and the IRR, components, monthly production values, detailed tables, shadow analysis images, heat maps, loss diagrams, and finally the cost of not going solar, because we all know it. If you are not going solar, if you don't have solar on your roof right now, you're actually paying more for electricity. So it gives you that final analysis as well. Finally, we ended with an impact on environment analysis, which helps the more environmentally conscious customers also understand the social benefit that they're making to society by opting for solar. Thank you for giving me the time, and Amit, over to you.
Thank you so much, Siddharth. Very interesting representation. Thank you so much. May I now call upon Mr. Lim Cheong Boon, Head of Product and Marketing, Trina Solar, Asia Pacific. His topic of discussion presentation would be today, Embrace the 600 watt new era. Mr. Lim, please.
Hello, thank you. Thanks again, everyone, to take our time today to participate in this session. So let me run everyone through quickly the latest development that we have from China. So first, we can take a look at the module trend that has been happening over the past 10 years. So in the beginning, you will see in the very beginning, it was only 290 watt for mono module, and the power bin has been increasingly steadily at about 5 to 10 watts per year. But especially over the last 2 years, you will see there's a big jump from the 400 watt, until now, the 550 watt and 600 watt that has been announced recently. So the trend has been much more intensive over the past 2 years. So of course, in terms of the project developers, the project owners, solar owners, we always look at the LCOE. How can we achieve a lower LCOE for our project? So the formula basically is the total cost divided by the total power generation. So what we are helping here is in terms of the cost, how we can use the module to lower the BOS cost and also increase our power generation so that you can get a lower LCOE project. So this is the Trina product roadmap over the next 3 to 4 quarters. So early this year, we have announced the 500 watt module. And then in July, we have announced the 550 watt module. So this is targeted to be available approximately about end of 2020. Then by first half of next year, we will also have the 600 watt module available to the market. And for that, beyond 660 watt or even higher, this one will be still under the planning stage, but we also will be aiming for modules in that power range. So this is the current Trina product portfolio for 2020. So we have a range of wafer size. So maybe as mentioned earlier by the other presenters that there's quite a lot of different wafer size in the industry now. But over here at Trina, we have the 158, which has been around for the past 4 years, and then we have also upgraded to 166. And then the next direction that we are going definitely is towards the 210. So over the next few quarters, we'll be increasing our capacity for the 210 mm wafer size. So as mentioned, we have launched our 600 watt module. So this is in a larger footprint, comprising of higher power in cell configuration 5x11 and 6x10 for the different power bins. So this is also built on our previous platform of the different technologies which are introduced in the next slide. So these are the technologies that we have deployed to achieve this higher power bin. So of course, starting from the top left corner is the wafer size, which have increased from the previous 156 era to 210, about approximately almost 80% increase in the surface area. Then for multi-bus bar also, previously we have from 5 bus bar, 9 bus bar, and now because of larger wafer size, we'll be using the 12 bus bar for our 550 watt module. And also for non-destructive cutting, half cut cell, this has already become standard in the current industry. And we also use the high density encapsulation method to reduce the cell spacing to increase the module efficiency. So just a bit more details, you can see the development of the silicon wafer over the last 50 to 60 years. So now for Trina, we are aiming at the 210, which is the current largest in the industry. And we do believe that this is the wafer size that will be adopted very soon by most of the manufacturers. Then this is the multi-bus bar technology, where we have replaced the flat ribbon bus bar using a round wire ribbon to increase the light capturing effect and reduce the shading effect on the solar cell. So this will also help us to increase the power bin of the module. Then as mentioned, on a non-disruptive cutting, so the conventional method, we are using the laser melting to create a insertion on the solar cell and then separate it by a mechanical separation. So this actually results in a cut surface at the edges of the cell. So for this new technology, we are using a low temperature laser to slice through the cell directly, so that this will give us a very smooth edge for the solar cell. And at the same time, the mechanical load of the solar cell is also not compromised. Then for the high density encapsulation, basically we have chosen the center one to achieve the balance between how we can achieve higher power and also maintain our current production yield. Then of course, we always get questions from customer asking, now that your module has become bigger, so is there any impact to our mechanical loading? So the good news is that we have also upgraded and reinforced our frame design so that it will be fully compliant to all the IEC standards and requirements. So these numbers here are the current estimation. We are still doing some ongoing testing, which we will conclude by the end of September. We don't foresee any big changes from the numbers shown here. So the details of the 550 watt, this is based on the 210 MSL and the technology that I've mentioned earlier. So the size is about 2.3 by 1.09, weight about 32 kilos. So Trina here is adopting a low voltage, high current design. So the advantage of this, we will talk about in the following slides. So similarly for 600 watt module is also using the same low voltage, high current design. So because of the lower VOC, we are able to connect more modules per string. So you can see here for this particular case study, when the site condition is -10° and a 1500 volt system, we can connect up to about 36 modules per string compared to only 27 modules for the other manufacturers. So that's about a 35% more power per string. So what this will happen is that the effects of this will cascade down to your BOS, where you will see the power used, the racking, the cables, all this absolute quantity will reduce because of the longer module per string and the higher power bin. So this will translate down to the savings that you can get for all these different components. So for this example here is the China project 100 megawatt fixed tube backsheet module with a 2-row vertical installation. So we are looking at a savings of about US dollar 0.007. So similarly, we have also done extensive studies together with third party. So DMVGL has also done the calculation based on a site in US, and we also compare between the different power bins of what we have in the market and what Trina is offering. So I would say it's pretty conclusive on how the higher power bin is able to allow our customers to get a lower BOS and also a lower LCOE. So these are some of the details of the calculation. So you can see, the key savings will come from basically on the DC cables, the DC installation, and also a little bit of on the AC installation. So overall, we can see approximately about minus 1.58% savings for BOS and minus 1.39% for LCOE. So this is quite significant, especially for the LCOE side. So this is an electrical diagram for a central inverter deployment. So you can see overall, basically the AC is unchanged. We still have the transformer, the power grid, and everything. So over at the DC side is what we need to do a little bit of changes, especially on the inverter, because the current now is much higher compared to before. And also, so we are working with different inverter companies to upgrade so that they can be compatible with these high power modules. So similarly for the string inverter also, we don't see big changes at the AC. The upgrading part is on the DC side, where each string input will be approximately about 20 amperes because of the high current of the solar module. So as mentioned, we are working with various inverter companies to upgrade their current inverters to be compatible. And similarly for trackers, so these large modules can be used together with the tracker companies for large-scale utility project deployment. So we have also get the compatibility letters from a few big major players for tracker supply. So overall, in the next 2 years, our capacity for this 210 mm module will be increasing tremendously from the current 10 gigawatt to 21 gigawatt next year and 31 gigawatt in 2022. So as you know, we also have the 600 watt alliance where from raw material supply all the way down to the panel, to the BOS, to the EPC design, this alliance has already been formed. So definitely the whole industry will be moving towards this 600 module. Okay, this is just one example where we can use the utility project, the high power module. And of course, the floating project is also something we can work on. So with that, thank you very much for your time. And back to you, Amit.
Thank you so much, Mr. Lim. Thank you. Now, may I please call upon Mr. S. Ramakrishnan, Director, Protonics Fortuner India Private Limited. His topic of presentation would be Future of Solar Power. Mr. S. Ramakrishnan, please. Mr. Ramakrishnan, your camera is off and you're on mute, please. Mr. Ramakrishnan? Ladies and gentlemen, just give us 1 minute, please. Ladies and gentlemen, we are sorry for the delay. There is some technical error. Mr. S. Ramakrishnan is joining another 1 minute, please. Apologies for the delay. There's a little technical snag at Mr. Ramakrishnan's side. He's just joining in. Apologies, ladies and gentlemen. We just received the message. They're just joining, and so sorry about that. I hope you would be part of the expo for the whole day. You know, this is the second edition of REI Expo. The first edition, which happened across the world, it was the first edition which happened 9th of June. Seeing to the huge craze, and we received a lot of queries across from a lot of countries and otherwise. We had today and yesterday we had 107 countries logged in to the expo. So REI Expo is being live telecasted at 107 countries right now, with attendees from 107 countries. And we've got many big brands which have joined in. And among them, the 9 brands had just presented, 8 brands have just presented over here. And we're just looking forward for Mr. S. Ramakrishnan to join any minute now. If you just give me 1 second, I'll just be back. Just give me 1 second.
Yeah, very good.
In fact, we've already lost a couple of minutes, please. Yeah.
Mute, right? Good.
Mr. Ramakrishnan, you can start talking meanwhile.
Okay.
We are running short on time, sir. We don't have
Okay.
Yeah.
Yeah. Good day, everyone. I'm sorry I got a little late and made you all wait. Ms. Amit, particularly, you've been so helpful. And Ramakrishnan here from the Protonics Fortuna Group. And I'm an electronics engineer with over 40 years of hands-on experience in power electronics and renewable energy. Solar chargers and IGBT-based powertrains are some of my key areas of work, and we are proud to be a name to be reckoned with in MPPT and static stabilizer technologies. In my talk today, I will cover briefly current PV systems and solutions, with particular emphasis on evolving MPPT techniques and future trends. Earth's natural resources are dwindling day by day, while the power demand is increasing. To meet the rising power demand, the power sector is forced to look at alternate energy resources. Renewable energy resources help reduce the carbon footprint, thereby helping the fight against global warming. Out of various renewable sources of energy, solar PV system stands out due to its simple structure. The efficiency of the photovoltaic system is substantially increased by using maximum power point tracker. Several algorithms have been developed over a period of time to track the maximum power point accurately. I would like to add that this is a continuing work in process in our labs, and we are fully equipped to cater to all domain user requirements. A photovoltaic PV system is made up of semiconductor devices which generate electricity when it is exposed to natural light. The building block of a solar panel is solar cell. A photovoltaic module is formed by connecting many solar cells in series and in parallel. To increase output voltage, the modules are connected in series, and to increase output current, they are connected in parallel. The major challenge, though, is to tackle the nonlinear characteristics of the PV array. The PV characteristics depend on the level of solar irradiance and temperature. The irradiance levels fluctuate due to passing clouds, nearby buildings, or trees. The PV systems have evolved, however, over time, and some of the notable developments are as follows. Floating solar farms, they're called photovoltaics, or photovoltaic solar power systems created for floating on reservoirs, dams, and other water bodies. Floating solar farms can generate huge amounts of electricity without using valuable land or real estate at costs less than land-based photovoltaic panels. Also, the power production is greater by up to almost 10% due to cooling effect of water. Now you have then what we call as a BIPV solar systems. They are called building integrated photovoltaics, seamlessly blend into building architecture in the form of roofs, canopies, curtain walls, facades, and skylight systems. Unlike traditional solar PV panels, BIPV can be aesthetically appealing rather than a compromise to a building's design. Then we have solar skins and solar fabrics. These are some of the things that are going to happen, change the way solar energy is harnessed in the future. While these are upcoming trends, technically speaking, photovoltaic systems are classified as grid-connected and standalone systems, which are designed to provide DC and AC utility power to operate independent of the grid. The grid-connected PV systems are designed to operate in conjunction with the electric utility grid system. They mainly consist of inverters with built-in MPPT tracker to convert array-produced DC into AC power synchronized with utility grid. A bidirectional interface allows the power to be drawn from the grid or fed back when the PV system output is greater than the load demand. They are also designed such that if the grid goes down for any reason, the inverter is turned off as a safety measure. This is called anti-islanding. Then we have the standalone photovoltaic systems. These are mainly designed to operate independent of utility grid and sized to supply certain DC or AC electric loads. The basic standalone PV system is a direct coupled system without batteries and operates only during sunlight hours, and the excess energy, if any, will not be stored. Many applications, the main applications are ventilation fans, water pumps, and solar thermal water heating systems. The other common variant is the one with battery backup. Off-grid inverters usually have a number of features designed to optimize the performance of your battery system. In addition, they are designed to work with lower voltages, given that the batteries are usually operating between 12 volts and 96 volts. Now coming to the maximum power point tracking, this control technique is used mainly to extract maximum available power from the PV modules under varying solar irradiation and temperature at any instant of time by maximum power point tracking algorithms. A number of algorithms have been developed to track the maximum power point efficiently. Most of the existing MPPT algorithms suffer from the drawback of slow tracking, due to which the utilization efficiency is reduced. A number of MPPT control techniques are in use today to improve.
Mr. Ramakrishnan.
Yeah.
Mr. Ramakrishnan. Sir,
Yeah.
good afternoon, sir. Sir,
Yes.
I'll have to humble you to stop us, sir, please, because we have a next session which is about to start, sir. and we got the session delayed by 5 minutes, sir, unfortunately. So I'm so sorry about that. And it was a very nice presentation. In fact, what we can do is we can share your presentation. If you can share your presentation with us, I can share it with the attendees who are watching the session right now.
That's
Would that be with you?
Yeah, that's fine. That's not an issue.
Thank you so much.
Just a minute. Yeah.
Yes, Rajat, I think you can close it. Thank you, Rajat.
Yeah.
And I would want to thank all our presenters for presenter presentations today. They were wonderful presentations. The link for the session would be available in due course of time, which I will share with respective companies, which can go across onto the social media, or if you would want to share with your customers or otherwise. Thank you so much.
Thank you, Amit. Yeah,
yes,
sorry for getting
Rohit,
late.
thank you so much. No, that's
Yeah.
okay, Rohit. Thank you so much.
Pleasure.
And I would, I would want to thank all our presenters once again for the precision of time and presenting their presentations so precisely. Thank you so much. Be safe, stay healthy. Our next session of the day is about to start, please. And I would request you to please enjoy the platform and visit all the companies, 22 companies which are present over there, and have a great business, please. Thank you so much.
Yeah.